Hello my dear students, how are you all? Welcome to Deeksha YouTube channel. I hope all of you are doing good. So today I'm back here with another session of KCET Masterstroke, okay, for mathematics of course, and it's going to be LPP and probability, which is we're going to discuss in the session today, okay. So as you know, LPP doesn't have a lot of concepts in it, so it doesn't require another session just for itself. So what I've done is I've clubbed the two chapters together, LPP and probability. I hope that's okay. So this is again going to be your last session for your PU2 portions in KCET Masterstroke. Next we're gonna start your PU1 portions as well. I know I've been seeing your comments that so when are you starting PU1 portions? Here it is. We'll start very soon. Okay. So now I know your time is very important, so I'll not waste even a single minute of it. Let's start with the session very quickly. What we have today for the first time is going to be conditional probability. Okay. This is a very important topic. Reason being, of course, question can come from here. Second thing is, in Bayes theorem, this plays a vital role. Even in the multiplication theorem also, this is used, okay? So that's why conditional probability is very important and useful to us. All of you agree? Okay. So let A and B are two events associated with a random experiment, okay? For any random experiment, we have two events from that experiment. Experiment A and event A and event B, okay? So probability of occurrence of A, it is known that, of course, means we are looking for to find the probability of the event A provided that B has already occurred. Event B has already occurred. I mean, basically event B has already occurred. As of now we have event B has already occurred that we have already with us, and after that event B has already occurred, what are the chances of event A to occur? Means on the top of event B that has already occurred, chances of event A to occur after that. Okay, so in that situation, in that scenario, the chances of event A we are looking to find out. That's why we call it as conditional probability, okay, for event A provided B has already occurred. Okay, so again we write this as in this format. Please check PA/P means P has already occurred. Okay, chances of getting or chances of the probability for the event A to occur is given by PA intersection B, means them occurring together, and you take the PB out. So PA intersection B divided by PB. Okay. Now since you know that, there's a lot of concept which is based upon next coming will be independent events, because we have bacha intersection present over here now. So again we have a lot of questions on it where we use the independent events. They'll define that event A and B are independent, and then we also use that condition over here to find some values, find some probabilities as well. Okay, that is there for us, don't worry. So I don't think it's written over here, but in the coming slides we'll discuss that as well. Okay, so again we can write this in another ways. What bacha, if I'm writing BBA, what it means is, now event A has already occurred. I'm looking to find the probability of the event B, the chances of the event B to occur after that A has already occurred will be given by simply PA intersection B, okay, upon PA. So whatever is over here, no, same comes over here. Please understand this, okay. One more thing, because we take out the event that has already occurred, that's why divided by PA. All right, one more thing, I hope you know this, but PA intersection B will be same as bacha PB intersection A. I know you all of you know this and don't have to write that, but just still wanted to mention this, because in some questions, no, I will not say anything, just refer this as my answer for the intersection part. Okay, so I'll just refer this instead of referring this. That's why I'm mentioning it over here. Okay, even in the PYQs will refer directly. What next we have? Properties of conditional probability. Okay, properties of, so bacha, I'll tell you what, the chapter is not very big. Okay, so there's conditional probability, there's of course total probability, and there is a Bayes theorem. That's all we have, and some questions on the multiplication theorem is there, but not relevant, not much. I think that is used in the cases of Bayes, and that's why we have to learn it, but not many. Okay, again after that in LPP we're going to learn one graph question just to understand the concept, and next we have some MCQs to solve. We'll solve them to complete our session. Okay, so please have a look for properties of conditional probability. What we have over here is, let E and F be events associated with the sample space S, okay, of the experiment, such that PF is non-zero, Then we write PSF or PFF is nothing but 1, sir. PSF, basically the event F has already occurred, and probability the chances of the whole sample space to occur bacha will always be 1, sir. Okay, great. Now what are we writing, sir? Probability of please check here, A union B conditional probability with F is given by PA conditional probability F plus PB, this time with F, and intersection of AB with F. This is a subtraction over here. I'll repeat myself. probability of union of A and B. Conditional probability with F means F has already occurred and we are looking for union of A and B. The probability of union of A and B will be given by probability of the A with the conditional probability of F means F has already occurred, looking for the chances of A. F has already occurred, chances of B, minus F has already occurred and removing the chances of A intersection B, event intersection of A and B. Okay, I hope this is clear, not difficult at all. Okay, where A and B are any two events associated with the sample space, same sample space, of course, S. Okay, also bacha, this you know, this is very important, very important. PEF will be given by 1 minus PEF as well. Okay, is it all right? So third one we have P E conditional F is given by equals to actually 1 minus PE conditional F. Okay, there's a dash over here missing bacha. It will be nothing but PE slash F will be equal to 1 minus PE slash F. Okay, E dash slash F actually. So it's going to be what? Think about it. It's conditional, right? We can show it like this. It's going to be bacha event E, event F. This is event E. This is event F. Okay. E dash with F will be how much, sir? Please check. It will be from here, this part. E dash, which means outside except for F. So it's going to be this, right? This is all E dash only, right? And you want to take the intersection with F, means this is your answer. Please check. This part is your answer. Okay. So from there, if you subtract from 1, what are you gonna get? This part, right? That's correct only, no? This is true. No, please check here. It will become P. Excuse me, sir. Have a look. Check here. It will become PE intersection F upon PF equals to 1 minus, please check, PE dash intersection F upon, what is it? It's going to be just simply PF. Okay. Now if you take LCM on this side, it will become P of F minus PE dash intersection F upon PF, right? If you check carefully, actually, this will become bacha this numerator. This thing will simplify to this numerator. Have a look. From the total PF, if you subtract this part, what will happen? You're gonna get this only, right? From the total intersection, I can show this to you again. Don't worry. It looks messy, right? Okay. So I'm saying that from the total intersection, okay, from the total F, which is nothing but, have a look, this total F. Okay. From if you remove this whole thing, or I can slate this again like this. Have a look from this part. If you remove this part out from here, what is left out now? Only this is left. Only this part is left. I think it looks very similar, but okay, we understand, right? Okay, not a problem. Chaliye, let's give me 1 second. I can show you that better. The different color over here. I'm talking about this part, right? That's your result over here. Please check. This is the result for this numerator. All right. Let's move on now. So we can see this also is true. We'll have a E dash over here. Let's move on now. What is next, sir? The question number 1. Let's solve it. One card is drawn from a well shuffled pack of 52 cards. All right. If E is the event, the card drawn is a king or a queen. Okay. So event E represents getting a king or a queen, and F is the event representing a card drawn is queen and or an ace. So queen or ace. Okay. Chaliye. So then probability of, okay, E slash F. So E conditional probability with F. You know this is going to be PE intersection of F upon PF. Excuse me, upon PF. All right. Just a second. Just a second, sir. Okay. Upon PF. All right. How do you write this now, sir? So we need PF first. So let's find PF over here. So PF will become, if you look carefully, it will become sir queen, okay, or ace. So total is 8 there. 8 out of 52. How much is that? 2 out of 13. And what about intersection, bacha? Think about it. If you take the intersection of this, what will happen? You have only one intersection over here, which is nothing but queen. This is the only intersection, queen, right? So I can take this as, please check, simply 4. We have 4 queens in a deck of 52 cards. So 4 upon 52, how much is that? 1 upon 13. Put these values in the given formula that we have for conditional probability. So 1 upon 13 divided by 2 upon 13 goes out. I end up with 1 upon 2. 1 upon 2. Option A is correct. Option A is right. Please have a look. Done. All right. Moving on now. So for all of you who are aspirants of KCET, that's why you're watching this video. Okay, I have an announcement to make for all of you who are somebody. If you are somebody who has taken the test series, very good bacha, you have done a very good job going into examination. You have the right tool in your arsenal. Okay, again, if you're somebody who has taken the free trial and later you will take the test series, good bacha, very good. You want to take something, some decision, but you want to be sure of it. Okay, but if you're someone who has missed out a chance to purchase this test series right away, please believe me, this is one of the best test series available, best content available for KCET, because we at Deeksha for last 25 years are producing very good result in the KCET section. Okay, so we want you to be part of our journey, and we want you to we want to be part of your journey as well. Okay, so please make sure that you are somebody who has purchased the test series right now. If you can't today, don't worry, you can take the free trial right away. Yes, you get 4-part test for free, 1 for physics, 1 for chemistry, 1 for biology, 1 for mathematics. Again, the questions will be as per standards, 60 questions in each paper. Okay, and what you can do is you can attempt the paper and later you can check the solutions also is given to you. Once you are enrolling for free, yes, you can enroll only for 0 rupees. Once you enroll for free, you get the access to 4 PDF question papers, also PDF solutions, and subject wise video solutions for each of the faculties for physics, chemistry, maths and bio. For maths, I'll be giving you the video of the solution. Okay, now apart from that, what happens is 31 paid test is also there. 31 paid test is also there starting from 17th of March. Okay, why that date? Because after that time exams will be mostly over in boards. Okay, so that's why we are starting from 17th of March. Okay, in that you'll have full syllabus and chapter wise test to you. Okay, and detailed video solutions with analysis. You have chapter wise one shot revision videos. You also have chapter wise insights for last 5 years of KCET papers. Okay, so I hope this is very intriguing. One more thing I want to tell you is, like bacha, you can see apart from this, we are having a very good platform. What you can do is you can access the test series live there. If you're somebody, let's say not able to, have the concentration, have the exam mode on, what you can do is you can write the exam mode, like properly you can sit for the examination. I know it's online, but still you can write there. Okay, you'll have a platform access, you can choose a answer, then move on to the next one like that. Okay, then submit your test paper, we'll evaluate and give it to you, answer and the solutions as well. Okay, so please make sure that you are somebody who is attempting, and also you get a leaderboard. When based upon your performance, you get to know where you rank across the students that is there in in our section, in our what you call in Deeksha who is writing examinations, right? So you get your you get across your peers, you get your rank, where you stand in the preparation right now, how can you improve, how can you get better, all of that will be there. So please make sure that you are somebody who has taken the test, again test series, and you are you can avail this offer right now at an offer of 1499 rupees. Okay, so the original price is of 3000 rupees, but you can get this at only 1499 right now. Okay, so please make sure that you are taking the test series today. If not today, taking the free trial is a must. Okay, let's move on now. I understand your time is very valuable, so will not waste any single minute of your time. I am very sure of that. Okay, I'm very understandable of your situation that you are in right now. Okay, so next is the multiplication theorem on probability. What is there, bacha? Let A and B are two events associated with sample space S. Okay, again it's defined very clearly. Then A intersection B denotes the event that both A and B have occurred. Okay, then event A intersection B is also written as AB, okay, chali. So basically what we have, from where this is coming, bacha, if you remember, no, please check here. PA dash B is nothing but PA intersection B upon PB. Multiply now. What do you get? PB into PAB, okay, or PA into PBA, all right, becomes equal to what, bacha? Becomes equal to the intersection of A and B. And we can write P and A and B as simply AB. You'll see where, don't worry. Okay, so again you should not have PA equal to 0 or B equal to 0. That's why they are both non-zero values, otherwise it will become undefined, right? Check here, not defined. Okay, so what do we have? Note, if A, B, C are three events associated with a random event, okay, experiment, what will happen? Same thing, bacha, we have intersection with three events over here. We write here PA times of PBA times of PC A intersection B, and next time what happens is this can be written as AB. Please check here. Same thing is there, just this A intersection B becomes equals to AB. In the case of 3 events intersection, please check. Okay, what is there now? Independent events, very important topic, again but very simple also, not important and difficult, important but simple. Okay, why important? Because useful in a lot of concepts, lot of problems you will see this statement coming in. What is that, bacha? For independent events, this is your everything. If you know this very well, your job is done. Okay, means if I have event A and event B as independent events, then I can say that their intersections probability will be equal to probability of individual events product. Probability of individual events product, that's all. Okay, if I take 3 events, I'll get same thing, PA, PB, PC, PA, PB, PC. How we get this, bacha? I told we have this condition, P A dash P will come to PA intersection B upon, of course, PB, which will lead me to PA times of PB divided by same thing, so PB. Cancel. What I get now? Simply PA. Simply PA. Is that clear? Is this clear? Please check. Same thing over here. Alright. What else we have now? Question number 2. A and B are 2 independent events. With the probability that both A and B occur is 1/6. So what they've given is A intersection B is nothing but given as 1/6. Okay. What are they also given? P. So basically what it means, bacha, they've given this to be independent events, right? So let's call this as PA into PB. That's what they've given. Let's call this to be X, this to be Y. So basically what they've given is XY equals to 1/6. 1/6, is that clear? Okay. What else they have given? Both probability that both A and B is this, and probability that neither of them occurs is 1/3. Okay, basically PA dash intersection with B dash is 1/3. I can write this again. It will become please check here, PA dash times of PB dash. You know the property for independent event, this also is true. Okay, so what I get, bacha, over here, 1 minus PA times of 1 minus PB equals 1/3. Not big a deal, very simple statements, right? Using the definition of complement of a event. Okay, probability of complement of event, 1 minus PA, 1 minus PB for PA dash and PB dash. Not big deal. Okay, so I can write here this as 1 minus X, and check here, 1 minus Y equals to 1/3. Now from here, bacha, I can do what? I can write the Y value. So Y will become simply 1 upon 6X now, 1 upon 6x, right? From here xy is 1/6 now, so I can take this x on the side, it will become 1 upon 6x. Okay, so what I have here, please expand, it will become 1 minus x, and I have 1 minus 1 upon 6x equals to 1/3, equals to 1/3. Can I expand it over here? Yeah, with I get 1 over here, and I get minus 1 by, please check, I get here x times of this, no, so plus actually, plus 1 by minus only, no, 1 into minus 1/6 I'm doing. For the first term I'm doing, bacha, I'm doing for the first term 1 with both the terms in the second bracket. Okay, I'll repeat myself, I'm multiplying both these terms with the first term of the first bracket. Okay, so 1 times of 1 is 1, 1 times of 1/6 will be 1/6 only, 1/6x, and you'll have a minus sign because of the negative sign over here. Next, what we'll have, minus x into 1 will be minus x, and I will be having last as minus x into minus 1/6x will become plus 1/6 equals to 1/3. Shall what next now? Have a look. I can continue from this side. Yeah. So I'll keep the numbers on this side and bring the variables on the other side. Okay. So I'll have 1, then I have 1/6, then I have minus 1/3 equals to, please check, it becomes x plus 1/6x, x plus 1/6x. Okay, great. Take LCM over here, we get 6 now. We get here 6 plus 1 minus 2, I guess. Yeah, over here LCM will be 6x again. I get here x square, sorry, 6x square plus 1. Okay, plus 1. Cancel this 6 and 6. So I'll have here 5 equals to 6x square plus 1 divided by x. Cross multiply now, please check. You'll have here 5x equals to 6x square plus 1, which will give me 6x square minus 5x plus 1 equals to 0. We know the factors very well. It'll become 2x minus 1, and you'll have 3x minus 1 equals to 0, right? Please check. 2x into 3x bacha is 6x square. I repeat myself. 2x into 3x, 6x square. 2x into minus 1, minus 2x. 3x into minus 1, minus 3x. Add them, minus 5x. And minus 1 into minus 1, plus 1. Clear now? Okay. What else we have from here? Please check. So from here we get, if I use the first bracket, I get x equals to 1 by 2. And second, I'm getting x equals to 1 by 3. What are they asking us? Probability of the occurrence of the event A. Let's call this to be event A, right? We have this as x over here. So x value is either 1 by 2 or 1 by 3. So option is given as only 1 by 3, no? So option D is right. Please check. Excellent question. Not difficult, but good question. Okay. Shall we move on? Of course. So what we have? Partition of sample space. Okay. So what we do in this case, we look for those parts. Okay. So let's say the events E1, E2, E3, so that until En, okay, are the part of the sample space given like this: E1, E2, E3, E4 up to En. Okay. So for them to be called as the partition, there are some conditions to be, that has to be fulfilled. What is that condition, bacha? They have to be mutually exclusive. They have to be mutually exclusive. Means not overlapping in nature. Please check. Not overlapping in nature. Is this and this overlapping, bacha? Is this and this overlapping? So none of the partition will be overlapping with each other. So mutually exclusive. Mutually exclusive. Okay. Chali. Exclusive. What text we have? They should be exhaustive in nature. They should have exhaustive nature, and also non-empty. This should also be non-empty. Can I take example of an event which is mutually exclusive, sir? Of course, I can take a coin toss. Let's say I'm getting heads. Can head and tail exist at the same time? Okay. So means they cannot, two events A and B cannot coexist. Cannot coexist, sir. Cannot coexist. Okay. And of course, exhaustive means at least one has to exist at the time. Means, for example, if you toss a coin, no, you will get at least one event, right? You'll either get head or tail. It's not like possibly like, neither of them can never be coming at once. Okay. Means for an event there will be, for any experiment there will be one event for sure. So they have to be exhaustive in nature. Okay. Chali. So then we have, so theorem of total probability. Let E1, E2, E and B, again partition of sample space S, and A be an event associated with S. Then we write, bacha, for partition E1 we write, what is it, sir? From where it's coming? From the conditional probability, right? What is this going to be? Please remember, E1 A. Same thing with E2 A. Same thing with E3 A, and so on till En A, right? And we write this in terms of conditional probability like this: PE1 times PAE1, means probability of the event E1 such that event En already occurred, and probability of the event A is also expected. Okay, please check. So same thing we can do, bacha, over here. We'll be giving what? We'll be giving total probability of the event A. Total probability of the event A. Please check. Okay, so E1, E2 for all the partition we are looking for. This is the condition. Okay, this is the this is your event A for the sample space S. We're looking at the intersection of this with all of them. So A with E1, A with E2, A with E3, A with E4, so on till A with En. Please check your intersection A with E1 till, what is this, sir? A with E1 to A with En. Okay, clear now? How this coming? From the conditional probability statement. Next, what we have, sir? The Bayes theorem. Okay, again see the same thing is repeating over here. E1, E2, E3 and En are mutually exclusive and exhaustive events associated with a random experiment, and A is any event associated with the same experiment, of course. Then we write this as, bacha, please remember that of course we write this as, what is it, sir? From here, please check, please check, please check. What is this, sir? This step is from where, bacha? This step is nothing but your conditional probability. Yes or no? PEI intersection with A upon PA, right? And how we write, bacha, PA to this? What is this, bacha? Your total probability. total probability. Correct, no? What is this, bacha? The multiplication theorem. Yes or no? PEI dot PAEI. Okay, for I belong from 1 to n. This actually from here to here, if I write like this, PEI, okay, EIA, directly if I write this, I get what? This is the statement of your Bayes theorem. Please check PAEI, and of course divided by, I can write here simply PA, no? The total probability. The total probability means for the event E1, okay, for the event intersection of A with the event E1 divided by total event probability of the event A. Okay, again with the A, E1, E2 and En. Okay, please understand this, very very simple. What now? I have taken a question like this. Let's have a look. 0.5% of the population has a particular disease, great, not great, I mean, like they have a disease, and I understand the statement, sir. Okay, and they have given one condition over here is 0.5%. Okay, means if you have to pick one person who is disease affected, we can write this, no? It'll be going to what, sir? It'll be going to be 0.05, okay, 0.5%, no? So it becomes a 0.005. That's the probability. Okay, so picking a person who is disease affected will be this. The chances of this is given like this, 0.005. A test is developed for the disease. The test gives a false positive 3% of the time, and false negative. False negative means somebody who is positive, that the result comes out as negative. That's the meaning of false positive, right? Sorry, false negative, right? False negative means somebody who is actually sick with the disease, the result is coming out to be negative. Okay, that's the condition. False positive means that that somebody who is negative in the actual disease, they don't have a disease, but the results comes out to be positive. Okay, so that's called as false positive. Chaliye, what is the probability that Amit, a random person, tests positive? Chaliye, so the event is that we're looking for. Okay, let's call this to be T. Okay, that's one thing. Before I start with that, have a look. So he's not saying that person should be sick or something like that. No, they're not saying that probability that event is Amit is actually sick. They're saying only the condition is that event T is that test outcome should be positive. Test result is positive. Test result is positive. Okay, now there can be two cases, bacha, for this. Okay, true positive, true test positive, and one is, bacha, false positive. False positive. So we'll find both these what do you call probabilities and add them at the end. That's what we're gonna do. Please check. So for true test positive, what should be the case? Please understand this. So we're looking for he is actually sick and test positive. And test positive. Please understand this. Actually sick and test positive, right? What will that be, bacha? Understand this. He is actually sick, okay, and test positive. Usually should happen 100%, but actually there's an error over here of 2%. How much is that? So will become 98%. It becomes a what? 0.98. 0.98. I hope this is clear, right? He is actually what? Positive, or so having the disease and test positive. There's an error in that. There's an error, means if I take this test, no, somebody, let's say I am sick with the disease, and if I go for the test, there are chances that even though I'm sick, it might come out as false negative. So we'll take this condition now. So I'll have to remove the 2%, that error I have to remove. So the chances of me getting this test positive will be what, bacha? Will be only 98%, because 2% I'm getting a false negative, right? So 98% is the result over here. So 0.98 is the probability. So this will become, bacha, please check. So basically positive, right? So I've taken this as positive only, no? Yeah, it'll remain same actually. PTD only, right? Yeah. Now 0.98 is, sorry, forgive me. What else now we have? Please check. Looking for PD, okay, times of, we are using the multiplication theorem, PT / T, okay. So will become, bacha, please check, 0.005 times of 0.98. I'll end up with 8 5s are 40, so 0. And what do you get? 5 9s are 45 plus 4, so 49. Okay, and I have how many places? 2 3 5. So I get here 3 is there, 0.0049, basically 0.0049. The chances of a case where test result is positive, okay, and he's actually sick. He's actually sick. Sorry. What is the next step, bacha? False positive. In this case, what will happen? Think about it. We already have. So chances of false positive means that he is not actually having the disease. False positive means he doesn't have a disease. So PD dash will become 99.5%. How much is that? It will be 0.995. The probability of this will be 0.995. Okay. Again, testing positive even though he doesn't have a disease. Testing positive even though he doesn't have a disease. T represents test result is positive. So testing positive even though he doesn't have a disease will be nothing but, please check here. So testing positive, basically what's a false positive? That's the meaning of false positive, right? Testing positive even though doesn't have a disease. I repeat myself. Testing positive even though he doesn't have a disease. That's called as false positive. So that's 3%. This will become 0.03, right? So if I'm writing the same thing, the multiplication theorem I'm using over here, PD dash times of P T D dash will become, please check here, will become 0.995 times of 0.03. Okay, multiply this 5 3s are 15. Okay, and then I have 9 3s are 27 plus 1 is 28. 9 3s are 27 plus 2 29. Okay, we have 2 and 3 5. They get here 0.02985. Let's add these two. So you'll have both the probability basically. Testing positive, it'll be testing positive, will be nothing but, please check here, when he is actually testing positive and he's actually sick, plus testing positive when he is not sick. Yes or no? A person can test positive whether he is sick or whether he is not sick, correct? So when he is sick, there's a chances given like this. When he is not sick, still testing positive is the chances over here. Okay, I've used this now. This is total probability, bacha. Please check. I'm getting this result as 0.0049 plus 0.02985. I can write a 0 over here just to make even decimal places. 5 plus 0 is 5, 8 plus 9 is 7 because 17, 1 is the carry. 9 plus 4 is 13 plus 1 is 14. 2 plus 3 is 3 only, and we have 1 0 left here. 0.03475 will become 0.035. If I round off on the third decimal place, answer will be option B. Please check. Option B is right. 0.035 is the correct answer over here. Over here what we are using, bacha? Total probability. Over here we are using the multiplication theorem. Please check. Excellent question. A very good question. Okay, I hope I was able to make it clear for you. Let's move on now. What is next, bacha? We have LPP now. Okay, so I've taken a graph question. I explained this entire process of LPP with the graph. Okay, basically what is the feasible reason, what are the coordinate point, what is the constraint, what are the non-negative constraints, everything I'll explain with the help of one question. Then we'll solve some questions in the objective category also. Okay, works. Determine the maximum value. What is this called as, sir? This is called as optimization. This is called as optimization. Okay, now understand this. Optimization, if I'm looking at this, first of all, optimization can be of two kinds. One is, bacha, maximizing the given objective function, and another can be, bacha, minimizing. So in the question they will not ask you to find the optimal value, rather they'll ask you to find minimum or maximum value. Okay, so minimizing or maximizing. So optimization is of two kinds. Okay, so but whether you get maximum value or minimum value, they're both called as optimal solution. So whether you get max, z max, or you're getting z minimum, okay, this is both called as your optimal solution. Optimal solution. Okay, understood now? Very good. First, second. Third thing, there's something called as feasible reason. Okay, so area bounded by, or whether it is unbounded also, area due to the constraints. So area that you receive, area, what do you call, that you receive or that you observe, area observed with respect to the constraint, okay, is called as feasible reason. Is called as feasible reason. Feasible reason. Okay, understood? Not clear the reason part, I can write that part again, not a problem. Feasible reason. Okay, so feasible reason, sir. Okay, now understand this feasible reason can be option A, unbounded also, and can be bounded as well. Bounded as well. But remember, understand this, whether unbounded or bounded, it will always be a convex. It will always be a convex shape. It will be always of convex shape. This is clear? Okay. So few things are listed down. Every point in feasible region is called as feasible solution. Every point. So we have every point in the feasible region. I'll show you the feasible region, don't worry. I've taken some questions, I'll explain that to you there as well. But every point in that feasible region will be a feasible solution. Every point in the feasible region is feasible solution. Okay. Not optimal. This is not optimal, bacha. Optimal is different. Whether maximum, minimum, I'm not talking about that. It will be part of the solution. Okay, means it will satisfy the constraint. I'll explain again. The understanding of feasible solution means is, if I have to explain that, I can understand this. So if I'm writing here feasible solution, it means bacha what? It means to satisfy all the constraints. All the constraints. Is that clear? That's the meaning of feasible solution. Okay. Optimal means that it will be a maximum or minimum value. Understood? Now after this, I think I've got everything covered. So corner points now. There's something called as corner points. Whenever your graph find intersections of the straight lines. Okay. Actually, we know one more thing is an objective function. Objective function is always of the linear form. Linear form. Okay, and when you draw these constraints and get the intersection point, no, those points are called as corner points. Okay, those points are called as corner points. Okay, and there's something called as non-negative constraints. Okay, so what we do over here, bacha, basically we talk about first quadrant. What it means is x should also be positive and y should also be positive. This is called as non-negative constraints. Clear? Simple definitions are there. Now let's look at the problem we have. So as you can see clearly over here, this is my objective function. Is it linear? Yes, it is linear. In two variable. It's a 2D plane. Okay. Subject to the constraint they have given, 2x plus y less than 6, x less than 2x, x less than 2, and x greater than 0. So these are your non-negative constraints. Okay. Let's draw the figure now. So if you check this out, what I'm getting. So what you do now over here is very simple. Take this first constraint without the inequality. Right here, y equals to 6. Take x as 0, you get y value as 6. X is 0, y value is coming as 6. When you take bacha y as 0, what do you get? You get x value as 3. Correct, now? When you take bacha x as 0, you get y as 6. When you get y as 0, x will become 3. So we have 0, 6 somewhere over here, and we have 3, 0 somewhere over here, and this is my line. This is my line. Okay. We're looking for less than means we'll go below this towards the origin. Okay. Non-negative will make only in the first quadrant. Please check here. What else now? X less than 2. So make x equal to 2 line. Okay. So behind this line. X less than 2 is over here only, no? This is x equal to 2 line. Now what line is this? It is going to be 2x plus y equals to 6. Okay. What is the required area, bacha, now? Can you see this? I hope you can see this. This is my feasible reason. You have all the corner points. This is going to be 0, 0. This point is how much, sir? This point is going to be 2, 0. Okay. This point is going to be, please check, 0, 6. And this is going to be how much? Please check over here. If you put x as 2, it will become 2 plus 2, 4. 2 only, 2, you know? 2, 2, right? Have a look. Y is 2. You put here x as 2 will become 2 into 2 is 4. Plus 2 will make 6. That's why the point is 2, 2. So that's your corner point. We have all the 4 corner points known now. Great. Okay, so let's write the coordinate points now. So z is given as 11x plus 7y right here, coordinate points and z value. What is the coordinate point now? First is 0, 0. Next we have is 2, 0, 2, 2 and 0, 6, 0, 6, 0, 6. Okay, so let's write the respective value of the objective function. It will be 0, no? If you put here x as 0, y as 0, will become both 0, right? So 0. 2 means 22 will become bacha, y will be 0, right? Over here we'll have 22 plus 14, am I right? 11 to the 22 and 7 to the 14, so I get here 36, I think. 36, please check. And you're looking for 0 and 6, right? It will become, please check here, 11 into 0 will be 0 only, 6 into 7, so 42. This is your z max value. This is your z max value. This is your z max value. Acha. So your answer will be coming over here. This is the position of z max. Now this is your optimal solution. Now I want to tell you one more thing. In some cases what happens, no, you'll find two maximum values. You find two maximum values. In that case what will happen? Let's say if I assume there was 2 points, this and this. In any other question we have 2 points as maximum value. Then every point on the line joining both the points, if I have, I'll repeat myself. If for this question answer is over here, please check. This is your answer, okay? No problem whatsoever. This is your answer. 42 is the maximum value. Question is done. We are done with the question. But I'm telling you what, if in a question that you're solving you get 2 maxima, then the maxima will exist at every point joining, every point on the line joining those 2 points. I'll repeat myself. If you have 2 maxima, then maxima will exist at every point on the line joining the 2 points. So if you join the line with the 2 maximum points, you'll have on every point on the line will be your maxima value. That is okay. Let's move on now. LPP is clear. Maximum value of z equals to 7x plus 11y. Subject to the constraint 3x plus 5y less than 26, 5x plus 3y less than 30, and we have 0, 0. Okay, so no problem, sir. Let's solve it quickly. We have to draw it roughly. It's a simple objective question. So let's take here x is 0, y is going to be 26 by 5. So almost this 26 by 5 comma this. When y is 0, you'll have x as, please check, you'll have x as, when y is 0, right, x will be 26 by 3. Great. Of course 0, this is your line, Hana? Less than or greater than? Less than means below this. Alright, what next we have? 5x plus 3y. When x is 0, y will be, sir, 10. X is 0, y will be 10 somewhere over here. Please check. 0 comma 10 I have. When y is 0, x will be 6, sir. 6 means somewhere over here. Okay. Please check. Okay, 3, 8, 24. No, it will be, of course, not over here. No, it will be over here, sir. Okay, somewhere on this point. Not, I should have taken the graph a little bit better, but all right. This will be a point called as, please check, y0 will be 6, 0. This will be 6, 0, this point. Okay, and also we have this origin, of course. So what is my required area? Have a look. This is my feasible reason. This is my feasible reason. Both are less than. Okay, what are looking for? Maxima. So we have few points over here, 0, 0, 6, 0, and this point. We need this point as well, right? So let's solve the equations to get this point. The equation is 3x plus 5y equals to 26, and we have here 5x plus 3y equal to 30. Okay, multiply this equation with 5 and this with 3. Why, sir? It will become 15x, that's why I want to eliminate one of the variable. So this will become, bacha, please check, it will become, sir, 15x and it will be 25y equals to 26 into 5. So 130, right? 26 5 is 130, na? Okay. And what about this, sir? 3 times of 5 will become again 15x. You'll have 9y and you'll have 90. Subtract it. Check the result now. So what I'm getting, it'll become cancellation after the minus sign. You'll become 16y. You'll have here 40. So y becomes, please check, 40 by 16. So 8 2s are 8 5s are. So I'm getting y as 5 by 2. okay, y as 5 by 2, which will give me, please check, it'll become over here, if I take the second equation over here, what I'm getting now, have a look, I'm getting here, sir, 5x plus 3y equals to 30, right? So right here 5 times of x plus 3 times of 5 by 2 equals to 30, right? Cancel 5, 5 and 6 times. Cancel, no? Okay. So getting here x plus 3 by 2 equals to 6. It means x equals to 6 minus 3 by 2, which means 12 minus 3, so 9 by 2. 9 by 2. Alright. Now, so your points, your coordinate points, if you see, is now we are having 0, 0, of course, that is not relevant to us. What next we have, sir? This point, no, 6, 0. Okay. What next, sir? We are having 0, 26. 26 by 5, of course, not visible clearly now. I'll change that. 26 by 5, 1 second. And the last point is nothing but what I got, 9 by 2 and 5 by 2. So I'll write it over here, the last one, 9 by 2 comma 5 by 2. We'll write the objective functions for this. So for this vector we get 0 only, na? And for the next one we get, so 7x plus 11y we have. So we get here 7 times of 6, so 42. And this is 0. 11 into 0 is 0 only. What if we get 7 times of 0 will be again 0. And for this I get 11 times of this, na? So 26 into 11 by 5. Okay. 11 by 5. Chaliye. So this will become how much? We can see it will be almost 5 5s are. So I can see here actually it is going to be 2, no? Almost 2, right? So 2.5 actually. No, 2.2, right? Yeah. 5 to the 10 and I get here another 10, so 5 to the 10 again. So 2.2. If you multiply 26 into 2.2, what I get? 52, 52, no? Have a look. So we get here 52, 52. So we get here 2, 5 and 5, 2, of course. So I get here 2, 7 and 5. Okay. So which will give me 57.5. Okay, because there's one decimal place over here. So it will give me 57.2 actually. Okay. So far this is the highest, 57.2. Let's check the last one. We have 9 by 2 and 5 by 2. So I'll get here 9 into 7 by 2 plus 11 into 7 by 2. So 2 is the LCM. I get 9, 7 is 63 and 77, giving me 7 plus 3 is 10. 7 plus 6 is again 13 plus 1 is 14 divided by 2. How much is that? 70, right? So this is the value of maxima, I think. Please check. 9, 7, 63 and 11, 7, 77 will have 70, correct, 40, 140 only, no. Answer will be 70, okay. So your result is nothing but 9 by 2 and 5 by 2. Option A is correct. Option A is correct. Please check. Maxima exists at this point because at this point you have 0, 42, 57.2 and the last is coming as 9 by 2, 5 by 2. Okay. So you can actually, what you can do, no, I'll tell you what. You can try solving at these 2 points. Okay, not these 2 points. Yeah. So these 2 points. Please check. If you get, I think you should be able to visualize from there only. Okay. You don't have to solve all the steps from your mind because they're not asking you actually the exact value of the maxima. They're asking you which point is maximum. That can become from that the answer. Let's move on now. Question number 6. The coordinate points of feasible region of inequality gives okay, coordinate points of feasible region, right? It gives the optimal solution, no? Whether maxima or minima doesn't matter, but it will give me one of those, right? And both are called as what, bacha? Both are called as my optimal solution only. I just explained to you right now. Whether you take maxima or minima, both are called as optimal solution, right? Okay. So this is it for your session today. I have completed both the chapters for you. If you have any doubt, you can ask me. If you want something else from these chapters, you can ask me again. Okay. And again, you'll have more sessions coming up for your question practice. But right now, this is it for the sessions on LPP and probability. I'll hope to see you again very soon. Till then, take care of yourself. Keep working hard. Bye-bye.